Okay, in this section, now that we know that if we take the derivative, we get n extrema. We don't know if it's maximum or minimum. Wouldn't it be nice if we had some way to determine if that extrema was actually a maximum or a minimum without having to do the sign chart? And we can do the sign chart, but aren't they kind of troublesome? You know, it takes lots of paper and you got to figure it out and all this stuff. So if we can have an easier way, and of course mathematicians I think are the laziest people I know. And that's why we have all these theorems and we have all these formulas and rules, is because we get tired of doing it the long way. We try to figure out a short way to do it, and here we go. Concavity. Let's talk first. What is concavity? Well, there's things called concave up and concave down. Now, concave up. If you have something that's concave, it means it has a depression in it. And concave up looks like that. Concave up. One way that I think about it is, because there are some textbooks that talk about convex. Convex up and convex down. I prefer concavity work, and I think of this, if you get confused, go ahead and feel free to use this. Coffee cup up. Is that a positive thing to have? It's got coffee in it, right? Coffee cup up is positive. So we're going to associate concave up with a positive idea. Now, somewhere in our discussion, we're going to get a negative value on this, but if we can determine that the curve is concave up, then we're going to be happy. Now, the negative thing comes in. If it's concave up, do I have a minimum or a maximum? A minimum, right down here, okay? A minimum value. And so if it's concave up, the negative, the thing that doesn't seem to match is that we have a minimum being less. But if you think about it as concave up being a coffee cup up, then it's a very positive thing. And that's what I want you to have stayed in your mind. If we do concave down, you know what it looks like? Okay? Coffee cup down, okay? Concave down, coffee cup down, same thing. Now, if it's concave down, I think that would be negative if you've got coffee in it, but you end up with a maximum value. So again, I'm going to try my best to help you find the connection between those. So let's see what we've got here. Given a function f, the derivative, let's move that slightly up and out of the way. The derivative, f prime is the derivative of the function, and f double prime, have we done second derivatives in here? The second derivative is the derivative of, I think there's an error in here. And f double prime, oh, no, let me read it myself completely here before I start expounding on it. Given a function f, f prime, single prime, is the derivative of the function, and f double prime is the second derivative of the function. Okay, so let's see here. We're talking about function f, and first f prime is the derivative of function f, and f double prime is the derivative of function f again. The second derivative is the derivative of the first derivative. Okay, so if I know what the derivative is, it's a function. I take the derivative of the derivative. How many of those can you take? As many as you can think of. Eventually you get down to a linear line, almost a zero line there, so there is a limit to what you can do, but you can always go below that if you wish. But we can take fourth, fifth, sixth, and seventh degree or seventh derivatives of something. We don't do that in this class, but we could. Okay, so we're talking about second derivative here. Now, determine the second derivative of this function. So the first part of this section is doing nothing more than saying, let's just get into the second derivative business, and let's take a look at those, and then we'll explain how that relates to concavity. So first derivative, now we have four terms. The function begins as a cubic, 3x squared plus 8x minus 5. So the first one begins as a cubic function. The derivative turns into a quadratic. What's the derivative of the derivative going to become? Linear. So the second derivative is the derivative of the first derivative, so we have plus 8. Yes, 6x. Right there it is. Okay. 6x plus 8. And it becomes linear. It's always 1 degree less than the derivative above it. Okay. Let's see. I want to add something to that. Some of you are having difficulty with the notation bit of it. Another way to write a second derivative, the first derivative can be dy dx, because we could write this as y equals, so dy dx. The second derivative, don't ask me why, is d2y dx2. Yeah, I know. I don't use that either. Okay? I don't know why they do that. The other thing we can do up here, we can say y prime. Here we could say y double prime. So usually the double primes are what we use. This one right here, it's there. Why they decided to put the 2's where they are, I don't know. They didn't ask me, okay? So I don't know. Okay, any questions on what second derivative, how we find them? Okay, let's look then. Let's see. We only have about a few minutes. Let's take the inspires. Let's see how quickly we can do this. Add another graph page. And I just want you to put the function in that we just did. X cubed plus 4x squared minus 5x plus 7. Oh boy. I didn't look at a window on this one first. I'm going to do what I never do. I'm going to do a zoom fit. There we go. I like being able to manipulate it myself, but we'll do this. Actually, I'm going to change the window just a little bit. And instead of having this be up here at 1547, I'm going to change it to be, let's see what 500 looks like. And we'll make this negative 500. Okay. Now we'll make it even 150. Just trying to get it so I have more space in there. Okay, I'll stop. I could finesse it a little bit better. Okay, I want to go to tab, and let's put in our derivative, 3x squared, and plus 8x minus 5. Now, I got an error. Let me correct this here. What is going to happen with the curve, with the derivative? How many zeros are we going to have for this? How do you know that? Yeah, extrema, whatever. Okay, so if I look at that, the first derivative is has an extreme there, and does it correspond to the 0 right down there? Okay, has an extreme point there. Does it correspond to the 0 right there? Yes. Now, here is the other thing, though. I'm going to back that off. Oh, shoot. I may have to just give this up because it's almost time. What I want to do is try and show you concavity. And to do so, I'd like to be able to shade this. And if I can you see that I have a shade over that? Don't look at my hand. Okay. To the left of my hand, would you say it's concave up or concave down? Yeah. To the right of my hand, concave up or concave down? Where does it change concavity? And that's a point we find using the second derivative, inflection point. So before we were looking at where the curve changes direction, where it's positive, then it changes negative. Here's where does it change concavity, and it changes somewhere in about here, maybe -2 or something. And so we're going to go in and look at that. Okay, I will see you on